Okay, let's start with the fourth chapter in third module, data mining. So coming to the introduction, let us go with the definition of data mining. So data mining is the process of discovering patterns in large data sets that involves different methods like machine learning, statistics, and database systems. It is an interdisciplinary field of computer science and statistics with an overall goal to extract information from the dataset and transform the information into the comprehensible structure for further use. Data mining is the analysis step of the knowledge discovery in databases known as KDT. It is also immersed in the context of pattern recognition. For example, the customers who buy cheese and milk also buy bread 90% of the time would be an useful pattern for a grocery store, which can then stock the products appropriately. Similarly, the people with the blood pressure greater than 160 and an age greater than 65 were at the high risk of dying from the heart stroke. Now, this kind of analysis is a great insight for the diagnosis purpose for doctors. Now, this such kind of mining technique is called as what? The predictive analysis. Now, let us see how to gather and select the data. So, the data can be gathered or collected from different available sources. The sources may be structured, unstructured, or maybe semi-structured. Now, coming to the unstructured data, it is based on the character and binary data like images, blogs, videos, chats, and the data that is generated from RFID tags, sensors, IoT, and data generated from different connected machines, etc. These data has to be processed first. That is, these data has to put in a rectangular shapes with clear column and rows before submitting it to the data mining process. Whereas coming to structured data, it is based on a relational database table. The example for structured data are the transaction and various concurrency techniques involved in RDBMS. So usually the structured data is stored in the rows and column and defined using schemas such as databases. So coming to semi-structured data, it is based on XML or RDF. Transaction is adapted from DBMS not matured. For example, versioning over tuples or graph is possible. Now, semi-structured data is more flexible than structured data, but less flexible than unstructured data. So, coming to data cleaning process. Now, what is data cleaning? Data cleaning is a process or it is an attempt to fill the missing values, smooth out the noise, identifying the outliers and correct inconsistencies in the data. Why data needs to be cleaned? Now, data has to be cleaned before pre-processing or before data mining process, because our data that is collected from different available sources may have the noise, outliers, or unwanted data. So data almost certainly needs to be cleaned and transformed before it can be used for data mining. There are different ways that data can be cleaned: by filling missing values, ignore the tuples, use a global constant to fill the missing value, use mean and median, that is the central tendency for attribute, etc. Now coming to data cleaning, there are different procedures or the processes that can be applied for data cleaning process. The first is what? Duplicate data needs to be removed. The same data may be received from multiple sources and needs to be removed. Filling missing values can be done in different ways, like we can find the average, the mean, median, etc. and all. Now data elements need to be transformed from one unit to the other unit. Then continuous values need to be binned into few buckets. Now let us go with these process with an example. Now I have created one dataset over here, which is very simple dataset, which is having quite few rows and few columns. Now usually when we talk about dataset, it should have enough number of rows to understand the data mining process or data cleaning process. Here you can see, now this is the first row which has a certain set of attributes which are called as what column. Now these are the tuples, or what you call it as the rows. The rows. Now usually there is 6 to 7 rows in this particular example. Usually a data set should have enough number of tuples or the rows. Now coming to the column or the attribute, there are how many attributes? There are 1, 1, 2, 3, 4 and 5 attributes, and the attribute names are city, USN. There are 3 subjects over there, like 15CS81 SMS, 15CS82 nothing but big data analytics, 15CS83 is IoT. And we can see over here, okay, the attributes is made up of the name also. Okay, let it be, no problem. Here there is the age and the name, which is not visible in this particular example. It is not visible over here. Now, so coming to the data cleaning process, the first process which can be applied for data cleaning is duplicate data needs to be cleaned. Now just observe these rows here. Where exactly are the duplicate data? The row, the second row, is there any duplicate data over here? As you can see, the third row and the 7th row has the duplicate data. So in a data set, if more than one row has the same values for the attributes, then such rows has to be replaced by one row. That is what duplicate data needs to be removed. Second process is filling the missing value. Now just observe these rows properly. Where are the missing values over here now? I think the 6th row has the missing value, where it has only the name. It is not visible over here. In such case, in the 5th row we can see first, second, third and 4th column. Coming to the subject 15CS81, the marks is not mentioned over there. That is the missing value. So such values used to be filled by some means. Now this can be done by using finding the average. What is average? Just find out the sum of this particular column divided by the number of rows. Right? Number of rows is 7. Sum by the number of rows is 7. We will get some value. The value may be, so for example, maybe 80 or 82 or something like that. That is average. That is one way. Second way is filling the missing value by means. What is a mean? It is just the average value or the exact the average value or the average value of the attribute. Then filling the missing value by using median. What is the median value? It is the middle value, or it is also called as the central tendency, the central value of that particular attribute. That is median. So we'll explain this particular with other example. I will make a separate video for this. Or you can fill the miss value by using a global constant like infinity or unknown, etc. See, for larger values, it is very difficult to find this average, mean, median, etc. and all. What I can go with is, I can just replace the blank value by using infinity, or maybe the value like unknown, etc. Then continuous values needs to be binned. What is binning process? What is the binning process? So binning is nothing but the same values or the continuous values need to be put in a few buckets. So for example, the salary of a person may be low, medium, and high. So for I can consider the salary as low if a person takes a salary below or salary below 20,000, and medium in between 20,000 to 40,000, and high above 50,000. Now, those persons who take the salary within 20,000 are grouped together. That is put into one bucket. That is what is binning process. Okay, the next topic is the outputs of data mining. So the outputs of data mining process can be seen in different ways or different forms like decision tree, regression, cluster analysis, association rules, etc. Now, what is decision tree? So in the first figure, we can see there is a hierarchical tree-like structure with the root node, the branch, and the leaf node. Now, this representation in data mining is called as a decision tree. So a decision tree is a hierarchical tree-like structure. It has a root node, the branch, and the leaf node. So the node represents the test, and the branch represents the outcome of the test, and the leaf node represents the class label. It's a classification technique. So in this example, we can see, so we are going to make a decision where a person is fit or not. So consider the age of a person which is less than 30. If it is yes, then it's lot of pizzas or something like that. If it is greater than 30, then excess in morning. Then come to the left branch. If the person eats lot of pizzas, if it is yes, then he is unfit. No, if it is no, then it is fit. Now, unfit and fit are the class labels. That is the outcome, exact outcome. So, we need to derive until the class label is correct or not. So, how we can draw this particular decision tree, or what is the inference output is what? If the age is 30, and if it is right, if a person eats lot of pizza, then he is unfit. If the person doesn't eat lot of pizza, then he is fit. Similarly, if the age is greater than 30, excess in the morning, he is said to be fit, otherwise unfit. That is the inference. Second output can be observed in the means of regression equation. So what is regression? Regression is a statistical technique. It is a statistical method, or it's a mathematical equation where it is going to establish the relationship between the independent variable and a dependent variable. Here the dependent variable is y because it is the value of y depends on the value of a, b, and the constant c, x, and y. A, b, and c are the independent variable. Now the regression equation or the result of the equation will arise in a best fitting curve where the possible values or the outcome may be best suited among the part of this particular curve. That is called as regression equation. The third form of output data mining may be the clustering. Now, what is clustering? The clustering can be best explained with this particular figure. So in figure A, we can see there is a collection of fruits that is put into one bag, say for example. Now in figure B, what I am going to do, I am going to group the fruit with a similar shape. So you can see the banana and there's some other green vegetable or green fruit that is grouped together because of the similar shape. Similarly, there is a fruit with grape-like structure that is grouped into one, that is grouped together. Similarly, the third group you can see the apple, banana, and so are grouped together. And in third figure we can see we have grouped all these fruits based on the color. For example, the yellow colored fruit is grouped into one cluster, the red colored fruit is grouped into other cluster. Similarly, the green colored fruit or maybe the vegetables are grouped into the other cluster. Now this is the process of clustering. Now why clustering is required? Now the clustering is required because of it is very easy to identify the outliers or remove the noise in a given dataset. The fourth form of data mining output is association rule. Now there's an example given over here now. Now what is association? See, if a person goes to a grocery store, buys bread and egg, may have high chance of buying milk. Now this is what actually association, where buying milk is directly associated with buying bread and egg. So you're going to learn about this in the coming classes. The next topic is evaluated data mining result. So data mining process can be broadly classified into supervised and unsupervised. So when we talk about supervised learning, we are dealing about classification problem. So when we talk about classification, so there are class labels, as I explained earlier, there are class labels. So when we talk about unsupervised learning, mostly the technique uses clustering. So when we talk about unsupervised, there is no class label. If there is no class label, then you should go for unsupervised learning technique. So coming to supervised learning technique, we have decision tree, regression, naive-based classifier, then SVM, support vector machine, etc. So coming to unsupervised, we have the techniques like clustering, then association rules, etc. Now coming to the classification or supervised learning, the accuracy of the classification technique is measured by the confusion matrix. Now what is confusion matrix? It is a matrix of true classes versus predicted classes. Now this matrix has 4 instances like true positive, true negative, false positive, false negative. True positive is represented by TP, similarly true negative by TN, false positive by FP, and false negative by FN. Now what are these instances? True positive are the values, are the predicted values correctly predicted as positive, and false positive are the predicted values incorrectly predicted as a positive, that is negative values predicted as positive. Similarly, false negative are the positive values predicted as negative, and true negative are the predicted values correctly predicted as actual negative. Now the confusion matrix is given as shown in this particular slide. So we can see it is a matrix of true classes versus predicted classes. So the first column in the first row is true positive, followed by false positive, then followed by false negative and true negative. So the accuracy is measured and is given by true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. And this is the way to find the accuracy in classification problem. Now this can be applied for decision tree, naive-based classifier, SVM, regression, etc. Now let us quickly go to different data mining techniques. Now as it is mentioned over here, the data mining techniques is broadly classified into supervised and unsupervised. When we talk about supervised, we have classification problem like, and this can be solved by using machine learning, decision tree, ANN, that is artificial neural network, statistical techniques and regression. So coming to unsupervised, we have again machine learning technique, cluster analysis and association rule. Now what is machine learning? So machine learning technique is nothing but we are training a machine to behave in a particular way. We are training the machine to identify a pattern. Now it can be used, so the problem can be solved either by classification or maybe by clustering or maybe unsupervised also. So coming to artificial neural network, and we discussed about decision tree earlier. So coming to artificial neural network, it is just like neural network that is present in the human body. So it is also called as deep learning. So what exactly is that ANN? It is a neural network which is an information processing technique that is inspired um, by different biological nervous system like as our brain process. So it is composed of large number of highly interconnected processing elements called neurons working in unison to solve a specific problem. Now, what are neurons? These are the just like the biological neurons, or just like a nerve cell, or simply neurons, which are the fundamental units of the brain and nervous system. These cells are responsible for receiving um, the input, but the sensory input from external world um, like the sensors, and giving the output through axons. Now, what is axon? It is a long, thin, tubular structure that works like transmission line. Again, you have to learn about this neural network in the coming classes. And we discussed about the rest of the techniques earlier in the earlier slides. Now, let us go quickly with different tools and platform for data mining. So, now a data mining process uses or it is possible to make use of different available tools, and these tools can be open source or it may be copyrighted also. You can buy from different organizations like IBM or SAP etc and all, or it is possible to download freely from the internet. So while choosing these tools we must be very careful because we need to um, solve a particular problem based on the analysis or the results we want to infer. Now, while choosing the tools, we must be very careful, and these tools should be simple or sophisticated. And the tools may be standalone or embedded. The tools may be open source or may be commercial. Now, a tool should have a proper interface which can able to make users or which can able to make the user to use this tool in a very easier way. Now, that these tools are different tools that we are going to use for data mining should support different data formats also. Now, what exactly are these tools now? Say, for example, the popular use tool um, is R tool, Veka tool, and IBM's SPSS modeler, and MS Excel can also be used for visualization, and Tableau can be used for visualization, etc. So, the next concept is data mining best practices. Now, what is the best practices? So, it is nothing but the business insight of data mining process. Now, this can be better explained by using a model which is called as cross-industry standard process, nothing but CRISP model. It has different process like business understanding, data preparation, modeling, model evaluation, and dissemination and rollout or the result. Now, what exactly is this model? It is a cross-industry process for data mining. It provides a structured approach to planning a data mining project. It is robust and well-proven methodology also. So we do not claim any ownership over it. Now, this model is an idealized sequence of events. In practice, many of the tasks can be performed in different order, or it will be often necessary to backtrack to previous tasks and repeat certain actions. The model does not try to capture all possible routes through the data mining process. So coming to the stages here, understanding. It is the first and most important step in data mining in business understanding. It is asking the right business questions. Whether this particular project can able to help out the business or can improve the business insights or not. Second, data preparation. Now, this is very important step in data mining process where data has to be cleaned and should be of high quality. The third process is modeling. So modeling is a very important task, and it's the actual task of running many algorithms using available data to discover if the hypotheses are supported or not. So high patience is required in engaging the data until the data yields some good insights. So different modeling tools and algorithms can be used over here. The next step is model evaluation. Now this is the step where we are going to check for accuracy. The last step is data dissemination and rollout, or the dissemination and rollout. Now it is important that the data mining solution is presented only to the key stakeholders and deployed in the organization. Otherwise, the project will be a waste of time and setback for the establishment and supporting database decision process. Now, let's go to the next topic, about the myths in data mining. So, there are usually 5 myths in data mining. Now, what are these myths? It is mentioned over here, right? Like, it's only about algorithm, and data mining is only about predictive accuracy, and data mining requires a warehouse, and it requires large quantity of data, and it requires technology export. Now, these are the myths. Now coming to the first myth, data mining is only about algorithm. No, data mining is not only about the algorithm. It is used by business to answer important practical questions, and then comes solving the problem. So when we are going to solve the problem after modeling, we require a suitable algorithm to solve this. Second myth is data mining is about predictive accuracy. No, it's not about only predictive accuracy. So it can be about the descriptive accuracy or descriptive mining and so. Third myth is that data mining requires data warehouse. No, it doesn't require warehouse in particular. So with the presence of data warehouse helps a lot in gathering the information. Sometimes creation of the warehouse can benefit from some exploratory data mining process. Some data mining problems may benefit from clean data available directly from the data warehouse. So data mining doesn't require data warehouse directly. So data mining is about large quantity of data. So data mining requires large quantities of data. So many interesting data doesn't require large quantity. It can be we can retrieve data from small or medium sized data sets also at low cost and low enterprise data basis also. So data mining requires technology expert. So many interesting data mining exercises can done by end users and executives using simple everyday tools like spreadsheet, MS Excel, or maybe some other tools like Veka, etc. and all. It doesn't require exactly the technology expert, but having a technology expert may ease the business or ease the process. Now the last topic in this module is data mining mistakes. Some commonly used data mining mistakes. Now what are these mistakes? Selecting a wrong problem. So without right goal or having no goal and without having a proper plan, if we select a problem, then the data mining yields in a wrong result. Now this could be wastage of time also. Second mistake is data without clear metadata. It is more important that the data mining process is engaged with the data than to have a lots of data. The relevant data required may be much less than we thought actually. So the collection of larger amount of data for a simple data mining task is useless. Third mistake is disorganized data mining. So without clear goal, much time is wasted. So doing the same test again and again or running the same algorithm repeatedly without planning to the next stage or without a proper plan would lead to the wastage of time and energy. The next mistake is insufficient business knowledge. So without deep understanding about the business domain, the results would be meaningless and it causes error in the results also. So the next mistake is incompatibility of data mining tools and datasets. So all the tools that is from the right from the first step, that is from gathering data till visualization, that is gathering, preparation, mining and visualization should work together. So it is possible to make use of different tools at different phases, and these tools must work together to yield a better result. So looking only aggregated values or results and not at individual records. It is possible that the rate results at a aggregate level provide different conclusions at different record level. So you must be very careful, not measure the results. At last we have not measure the results. Once we get the result, we must validate the result whether it is right or not. We must check with accuracy, etc. and all. Now, there are certain mistakes in data mining.